Assalamualaikum and hi everyone, so welcome back. Jadi dalam video kali ini kita nak discuss dua set soalan exercise berkaitan dengan persediaan bagi UPS 1 untuk semester 1 yang akan cover chapter 1 sehingga chapter 3. Jadi sebelum awak teruskan tengok video ini, apa kata awak cuba jawab dulu soalan-soalan bagi set 1 dan set 2. Jangan lupa untuk tekan link pada description video ini, terdapat dua link berbeza dan ada dua set soalan. Jadi apa kata awak cuba dulu jawab sebelum kita proceed pada discussion. Okay? Alright, jadi jika anda telah selesai jawab semua soalan di Google Form, berapa markah yang awak semua dapat? Okay, so jom kita mulakan dengan soalan yang pertama. So the physical quantity with the same dimensions as work is, alright, so bila saya baca soalan ni, this is very easy sebab dimension yang sama dengan work. Alright, so as we know, work, the unit is joule. Okay, so jadi apa physical quantity? Power, energy, pressure and momentum. So kita tahu power unit dia apa? Power the unit is watt. Okay, and energy the unit is joule. Okay, and pressure the unit is pascal. And momentum, okay, momentum the unit is kg. Kalau tak ingat, momentum P is equal to mv, it is kg meter per second. Pressure ni selain daripada pascal, you boleh tulis jugalah, pressure is equal to F over A. Okay, jadi tak perlulah kita cari what is the unit for pressure. Jadi untuk soalan ni, untuk menjimatkan masa, kita tengok sahaja apa physical quantity di bawah ini yang ada sama unit dengan work. So kalau kita nak buat juga apa itu dimension untuk work, kan? So kita nak tahu work is equal to, formula dia apa? F S, okay? And F is a force, so dimension of work is equal to dimension of F, okay, times dimension of S, displacement. Alright, and force, okay, kita tahu force, it is MA, so dimension M times dimension A times dimension of S. Okay, so M dimension for mass is capital M, dimension for acceleration is LT negative 2. Okay, and then dimension for displacement is L. Therefore, kalau soalan minta kita kira ataupun cari dimension of work is equal to ml squared t negative 2. So this is dimension of work. Alright, tapi untuk soalan ini kita tak perlulah kira ataupun cari dimension untuk setiap ini, nanti lambat. Okay, kita tengok saja pada unit of work iaitu joule and unit of energy also joule. So the answer is B, second one. Okay, next, what is dimension of force? Okay, so kalau ini kita tak hafal, kita boleh tulis sikit lah kalau kita nak tengok pada dimension of force. Okay, alright, so next question number 2, what is dimension of force? Okay, so kalau kita tak ingat dimension of force, kita boleh tulis sikit lah. So tak perlu kira pun, tapi kita boleh cari dimension of force is equal to F is equal to M times dimension of acceleration. Okay, so dimension of mass is capital M, alright, and dimension of acceleration is LT negative 2. Therefore, dimension of force is MLT negative 2. Alright, so the answer is B. Very easy, right? Okay, so proceed to the next part. Okay, so which of the following is the correct arrow to show the direction of F1 in X component and Y component? Means that this question asks us to resolve F1 into X component and Y component. So now look at the arrow. So this is the tail of the arrow and this is the head of the arrow. Alright, so direction. Okay, so this is F1. Sorry. Okay, alright, so this is F1. Alright, so this is the tail of the arrow. Make sure you know how to resolve. Alright, and this is the head of the arrow. Okay, so you can resolve from the tail. Okay, kita pergi ke arah head dia. So this is F1X, and then from the tail we move downward. Okay, towards to the head of the arrow. So this is F1Y. Okay, so means that F1X is to the right and F1Y is downward. Okay, so jawapan mana yang betul? So the answer is C. Okay, so next question number 4. An object has uniform acceleration if the velocity is, okay, when we have a graph, remember, when we have a graph of V against T, okay, so the answer is increase linearly, means that the straight line graph. Okay, so when the velocity is increased linearly, so jadi kalau kita kira the gradient of the VT graph, okay, so the gradient will give you uniform acceleration where A is equal to constant ataupun kita kata nilai acceleration dia adalah uniform. Okay, jadi jawapannya yang paling tepat adalah B. Kenapa bukan increase exponentially? So kalau increase exponentially, A is not uniform. Alright, remember V against T. Okay, so let's say increase exponentially. Okay, macam ni lah. Okay, so kita boleh nampak that acceleration here, okay, the gradient is increasing. Kecerunan dia semakin bertambah. So that's mean the acceleration is not constant. A is increasing. Okay, jadi soalan minta kita fokus kepada uniform acceleration ataupun constant acceleration. Boleh? Alright, so finish question 4. And then question number 5. Okay, an object moving along a straight line is decelerating. Okay, so the object is decelerating. Which one of the following statements concerning the object's acceleration is necessarily true? Okay, so the first one, the value of the acceleration is positive. Okay, so salah lah sebab dia decelerate. Okay, moving in a straight line. Okay, so kita tak boleh kata acceleration dia positif sebab dia tak bagi tahu objek tu bergerak ke kiri ataupun ke kanan. So kita tak boleh consider dia sebagai positif. Okay, kalau objek itu bergerak ke kiri, okay, let's say the object is moving, okay, so let's say the object is moving in this direction, okay, and then dia decelerate, okay, decelerate. So acceleration dia boleh jadi positif because V is to the left, so V dia akan jadi negative direction. Right, negative direction. Jadi kalau decelerating, that's mean V is decreasing. So kalau kita kira dia punya acceleration, dia akan jadi V final minus V initial over time. Okay, let's say kita letak satu nombor. Okay, V final because dia decelerating, so V final dia akan jadi kecil kan, but it's moving in negative direction. So negative 2 minus V initial, let's say lah V initial dia adalah 4, negative 4. Okay, so T. So dia akan jadi negative 2, T ni letaklah apa-apa nilai, contohlah 1 second, in 1 second, plus 4 over 1. So kita akan dapat nilai dia adalah 2, positive 2 meter per second. Okay, so jadi untuk soalan ini dia tak cakap objek itu bergerak ke kiri, dia kata just moving along a straight line. Okay, so kita biarkan dulu untuk yang pertama. Second, the direction of the acceleration is in the same direction as the displacement. Okay, salah lah sebab dia decelerating. So if the direction of the displacement is to the right, means that the direction of the acceleration must be opposite direction with the motion. Okay, and then this one, an object that is decelerating always has negative acceleration. Salah. Okay, ini yang saya dah tunjukkan tadi. Objek yang decelerating, kita kena tengok direction of the motion. For example, for this one, the direction of the motion is to the left. Okay, and then the object is decelerating. Okay, here, decelerating. V is decreasing. Okay, so kita provekan dengan calculation. Maknanya V final dia 2. V initial dia 4. Okay, and negative here is the sign for the direction. Okay. So, kita akan dapat positif lah. So, objek yang decelerating bukan sentiasa negative acceleration. It can be positive based on the direction of the motion. Okay. And then the last one, the direction of the acceleration is in the direction opposite to that of the velocity. Betul? Okay, means that, let's say the direction of the velocity is to the right, but the direction of the acceleration is in opposite direction. Okay, so the answer yang paling tepat adalah yang D lah, yang terakhir sekali. Okay, so question number 6. The distance traveled by an object is equal to the distance travel. So look at the type of the graph. So displacement time graph. So ini salah, gradient. Velocity time graph, gradient salah. Gradient of velocity time graph akan bagi you nilai acceleration of the motion. Okay. But the distance traveled by the object, okay, kita boleh kira bila kita guna ini pun salah lah, area under displacement time graph. Okay, the last answer is the correct one. Where when we want to calculate the distance traveled by an object, we can calculate the area under the velocity time graph. So this is the answer. Okay. Alright. So next, question 7. Alright. So here we have a diagram here. So based on the diagram below, which statement is false? Okay, so dia nak false statement. Alright, so we have A, B, C. So this is a projectile motion where the object is projected at an angle of theta. Okay, so kita ada dua kan, kita belajar. Projected horizontally. Contoh kita ada, Contoh kita ada macam ni, table. Projected horizontally. Ataupun kita projected an object at an angle of theta. Okay, so here we have theta. So we have here U, UX. We need to resolve into UX and UY. Okay, so now let's read the answers. Okay, so the first one, the vertical velocity at point B, okay, is equal to the horizontal velocity at point A. Okay, so at point B, kita tahu this is the maximum height. Jadi at maximum height, always remember, apa yang kosong at maximum height? Okay, at maximum height, the vertical velocity Vy is equal to 0. Okay, tapi ada tak nilai Vx at maximum height? Vx masih ada nilai at maximum height, which is equal to Ux. Always remember that Vx, okay, always equal to Ux at any point. Okay, at any point along the motion, nilai Vx akan sama dengan Ux. Okay, jadi untuk jawapan yang A tadi, the vertical velocity at point B is equal to 0. Betul lah, vertical velocity refer kepada Vy, which is equal to 0 meter per second. Okay, so dia nak kita cari yang salah. Okay, and then second one, the horizontal velocity at point B is equal to the horizontal velocity at point A. Betul? Okay, sebab okay, Vx at point B, okay, horizontal velocity at point B always equal to Ux, okay, at point A. So betul, yang ini betul. Okay, and then next, horizontal velocity at point C is equal to 0. Bila objek, okay, ni tadi kita tengok, kita lukis sekejap. So when the object reach point C, so dia akan ada macam ni lah, okay, VC, and then this is VCY and VCX. Okay, VCX is always equal to UX, but for VCY, vertical velocity at point C not equal to 0. Kita kena kira nilai ini, VCY yang saya highlight dengan warna biru. Okay, so dia tidak boleh equal to 0 lah. So ini jawapan yang salah. Okay, and the last one, the object is not projected horizontally. Betul, ini bukan case projected horizontally. Alright, so the answer is C. Okay, next, question number 8. Alright, so here we have a ball is thrown at angle of 20 degree from the horizontal surface on the ground. Okay, so means that we have the object is projected at this angle. Okay, 20 degree. Okay. The ball rises to some maximum height and falls back towards the surface of the ground. Which one of the following statements concerning this situation is true if air resistance is neglected? Okay, so the first one, as the ball rises, its acceleration vector points upward. Okay, maknanya dia punya acceleration, bukan dia punya Vy. Okay, dia kata acceleration vector dia points upward. So betul ke? No, salah. Okay, acceleration vector always directed downward. Sebab bila objek bergerak in free fall motion ataupun in projectile motion, the object is moving under gravitational acceleration. Jadi at any point, acceleration dia akan pointing downward. Macam tu. Boleh kat sini ke sama. Okay, sebab dia kata acceleration. So salah lah. So final velocity of the ball is 0 just before it reach the ground. Adakah final velocity at this point? Kita letaklah point A, ni point C. Adakah point C kosong? Tidak. Kita boleh kira dekat sini VC. Okay, so kita akan ada VCX and VCY. So at point C, kita perlu kira what is the velocity of the object just before it hits the ground. So we're going to have Vx squared, Vcx squared plus Vcy squared. Kena kira lah, tak boleh kata dia kosong. Okay, next. The velocity in y component of the ball is negative while the ball falls back towards the ground. Betul? Maknanya masa dia turun ke bawah, okay, remember that the velocity in y component, kita akan ada, contohlah ini apa? Point B, ini point D. Okay, so VBY pointing downward, VDY also. Okay, and this is also VCY. Okay, the direction of the vertical velocity must be downward, which is negative. Okay, but the VBX to the right, VDX also to the right, and the last one is VCX is also to the right. Okay, so kita recall lah balik. At any point here, nilai VBX, VDX dengan VCX ni sama. Sama dengan siapa? Sama dengan nilai UX dekat sini. Okay, sama dengan nilai UX dekat sini. Boleh? So jawapan yang paling tepat adalah C. Kita baca yang D ni pula. The acceleration of the ball is 0 when the ball is at its highest point. No, the acceleration is not equal to 0. Okay, yang equal to 0 adalah dia punya Vy. Vy dia equal to 0 meter per second at maximum height. Okay, so finish question number 8. And then question number 9. Alright, the principal conservation of linear momentum P is equal to mv equal to constant depends on the following statements except. Okay, except the first one. Total momentum in a closed system remains constant. Betul. When the net external force on a system is 0, means that in a closed system, no external force. Okay, the total momentum of that system is constant. Pun betul juga. Okay, next. When there are no external forces acting on the system, the total momentum before collisions equal the total momentum after collisions. Betul. Okay, and the last one, when the total momentum of the two spheres before collisions equals the total momentum after collisions, the momentum is not conserved. Salah. Jawapannya kalau sama, total momentum before collision and after collision means that the momentum is conserved. Okay, so jawapannya apa tadi? Dia kata accept kan, yang tak betul lah kan, so the answer is D. Alright, question number 10. Which of the following statements is true about the inelastic collision between two objects? Okay, the total momentum and total kinetic energy is conserved. Salah. Okay, remember inelastic, apa yang conserve? momentum saja yang conserve, but kinetic energy before total kinetic energy before and after collision is not conserved. So jawapan yang paling tepat adalah D lah. The total momentum, bukan, D pun bukan. Okay, total momentum conserve, okay, but the total kinetic energy is not conserved. So the answer is B lah. Okay, next, what are the forces exerted on a static object placed on a rough inclined plane? Okay, so the inclined plane, kena tahu how to draw the free body diagram. Okay, so untuk jawab soalan ni tak perlu lukis pun, tapi saya just nak explain sahaja. Okay, so we just recall how to draw the free body diagram. Okay, contohlah objek ni, dia mungkin akan bergerak jatuh ke bawah based on the gravity, right? So the frictional force should be opposite direction. Okay, so dia akan ada weight straightly downward. Okay, and we're gonna have normal force. Okay, so sebab dia static friction, so tak ada lain ni. Okay, V, so dia ini adalah Fs. Alright. So static friction inilah yang akan tahan objek ini daripada bergerak ke bawah. So ada 3 lah, normal force, weight and static frictional force. So ini. And then the second last question, which of the following represents an object that move with a constant velocity? Okay, object that move in constant velocity, okay, kita tahu kan, kalau static equilibrium, total force in x component equal to 0. Total force in y component also equal to 0. Means that the object is not moving in static equilibrium. Okay. Tapi kalau objek itu bergerak with constant velocity, okay, kalau dia bergerak in x component contohnya, so total fx equal to ma. But since the velocity is constant, so acceleration dia akan kosong. So kita akan tulis macam ni jugalah. Sama juga kalau objek itu bergerak in y component with constant velocity, so dia akan jadi macam ni, kosong. Kan? Kita boleh tulis macam ni. Ini kosong. Okay? So maknanya, apa bezanya, apa nama ini? Ini objeknya yang dalam kotak warna biru, objek dia bergerak. The object is moving, okay, in dynamic equilibrium. Means that moving with constant velocity. Yang ini dia langsung tidak bergerak. Object is in static equilibrium. Okay, so the answer is B. And the last one, which of the following is the tendency of an object to maintain its state of motion? Okay, so antara keempat ni, deceleration, momentum, inertia, impulse. Okay, tendency of an object to maintain its state of motion referring to inertia. Okay, so let's submit the answers. Okay, so berapa kita dapat? Okay, bas kita verify dulu. Sekejap. Okay, kita tengok jawapan kita betul tak? Full mark tak? Yay, full mark. Alright, so kita dapat full mark lah, 13. Okay, so finish exercise number 2. Ini saya discuss exercise number 2 dulu. Alright. So now, let's proceed to exercise number 1. Okay. So this is exercise number 1. Okay. So let's start. Alright. The first one. So this is the definition of dimension. Dimension is defined as a what? Which D can be expressed in terms of combination of what? Okay. So let's dimension is defined as a method. So A dengan B dah salah. As a method which the physical quantities can be expressed in terms of combination of basic quantities. Okay, so the answer is C. Very easy. Next, itu kena hafal lah. Okay, so which of the following quantities has a magnitude but no direction? Means that mana quantity di bawah ini yang scalar quantity, bukan vector. Okay, force adalah vector, displacement vector, velocity vector. The answer is energy. Okay, ni senang sikit kot. Sepatutnya kita buat set 1 dulu tadi, baru buat yang set 2. Tapi tak apa, sama je kan. Okay. Number 3, if vectors x and y are added, then the resultant will be best represented by vector. So x and y, so means that x in this direction, x in this direction, and then y in this direction. Means that the resultant vector should be in this direction lah. Okay, so the answer is C. Very easy. Okay, ini dia nak uji awak punya resolving vector. The graph represents an object that is, okay, this is distance time graph. Tengok distance time graph. So this is the straight line graph. Okay, so we're gonna have distance times t. Okay, so kita ada ini. So the gradient akan bagi you nilai velocity lah. So here velocity is constant. Dia punya kecerunan dia sama je kan. So velocity dia adalah constant. So increasing speed away from the start, salah, velocity dia constant. Moving away from the start at constant speed. Okay, decreasing speed towards the start, salah. Moving towards the start at constant speed, salah. Yang paling tepat, okay, dia start daripada 0. Look at here, start from 0. Kan, 1, 2, 3. So this is positive value, contohlah 10 meter. Kan, so maknanya dia moving away from the start at a constant speed. Okay, B yang paling tepat. Next, question number 5. Which of the following statements is true about acceleration? Acceleration has the same sign as displacement. No. Acceleration always has the same sign as velocity. Tidak. Okay. Always has negative sign. Tidak juga. Okay. Kadang-kadang acceleration boleh jadi negatif dan positif. Yang paling tepat tadi yang kita discuss masa set kedua tadi. Okay, kita kata apa? Sign of acceleration depends on both direction of motion dan juga how velocity is changing. Sama ada velocity dia decreasing ataupun velocity dia increasing. Lepas tu kena tengok juga motion of the object. Motion of the object ke kanan ke kiri. Okay, so acceleration boleh jadi positif, negatif bergantung kepada pergerakan, arah pergerakan objek dan juga bagaimana velocity itu berubah, berkurang ataupun bertambah. Okay, so jawapan dia adalah C. Alright, question number 6. Diagram shows the velocity time graph. So here we have positive V. So V is increasing and then V is constant. And then dia increase balik. Alright. Which acceleration graph represents the same motion as the object? So ini soalan bagi velocity time graph. Tapi dia minta kita pilih acceleration time graph. So look at this graph. So from 0 to here, so positive. Okay, the gradient, kecerunan dia adalah positive. But the gradient is constant. Sebab ini adalah straight line graph. So antara A, B, C, D, A dengan C ni dah salah lah. Kenapa? Sebab acceleration dia kat sini negative value. Sedangkan gradient dia adalah positive value. Okay? So antara B dengan antara B dengan D lah. And then the object is constant. Moving with constant velocity. So constant velocity, acceleration kita akan 0. Betul? Okay, betul. But last one, okay, from here to here untuk quadrant yang ketiga, okay, ataupun untuk section yang ketiga, the velocity still increasing. Maknanya acceleration dia adalah positif. Okay, so the gradient is the positive gradient. So acceleration dia akan jadi nilai positif. Okay, so ini salah lah. So the answer is B. Next, the distance traveled by an object per unit time is called. Ini ramai yang salah sebab apa? Sebab soalan tak kata displacement. Soalan kata distance travel. Okay, S over T. Okay, remember V is equal to S over T. Okay. Tapi V equal to S over T sebab dia dah mention dekat sini ini adalah distance. So bila distance, V itu bukan velocity tetapi kita consider distance adalah scalar quantity bahagi dengan masa. So V here is the speed of the object. Boleh? Okay. Next. How can you describe the motion shown in the graph below? So this is the graph S against T. Okay, means that the object is moving in positive direction. But adakah dia speeding up? Tidak. Sebab kalau kita tengok straight line graph, gradient of the graph akan bagi you nilai velocity, right? Okay. Ataupun Kalau ini kita nampak lah, kalau kita dah sebut dia punya direction, the object is moving in positive direction with negative velocity. Salah, sebab ini adalah kecerunan yang positif. So the object is moving in positive direction with constant acceleration. Tidak, bukan constant acceleration, tetapi constant speed ataupun constant velocity. Okay, kenapa kat sini dia sebut speed? Sebab dia dah sebut dia punya direction dekat sini. The object is moving ke arah mana? Positive direction, dan dia punya speed ataupun V dia adalah constant. Okay, constant speed will give you zero acceleration. So yang B ni salah lah. Okay, so the answer is D. Next, when the speed of an object is double, its momentum is P is equal to mv. Okay. So, bila soalan tanya double, triple, twice, half, so kita kena jawab tu, kita tak boleh kata dia decreasing or increasing sahaja. Okay. So, bila dia kata second case, dia punya speed double. So, P prime is equal to mass is constant. So, 2 kali V. So, dia akan jadi P prime is equal to 2 mv. Okay, where P prime is 2 times P. Iaitu double lah, 2 kali P. P prime 2 kali P. So, dia adalah momentum dia akan jadi double. Okay, bila speed of the object is double. So, the answer is B. Number 10. In an elastic and inelastic collision, the total momentum before a collision, is equal to the total momentum after a collision in a closed system. Ini adalah definition of conservation of momentum. Alright, very easy. A car towing another car using a chain. Alright, okay, look at here. We have 2 cars. Okay, car A, this is the chain, and car B. Okay. The force exerted on a chain is an example of which of the following force? Okay, the force exerted on a chain. Okay, so kalau kat sini kita lukislah paling tepat sekali, bukan weight lah kan? Applied force, frictional force, okay, tension force. Kalau kita lukis T, okay, dia akan jadi macam ni T. Okay, so the answer is tension force. Okay. 12. When you jump on a diving board, okay, you push down on the board. Okay, you tolak ke bawah and the board pushes you up. This situation applied to the action-reaction force. Okay, so action-reaction force merujuk kepada Newton's third law. Very easy. Okay, dia kata you tolak ke bawah akan ada satu, iaitu force from the board on you will push you up. Okay, so dia relate kepada Newton's third law. And the last one, what force opposes gravity when an object is on a surface? Okay, object atas meja, so kita ada weight, where weight is equal to mg, ataupun nama lain bagi weight adalah gravitational force lah, force due to gravity. Lebih mudah, force due to gravity. So what force opposes the gravity here? So means that the answer is normal force. Okay, so the answer is B. Very easy. Okay, so let's submit the answer. So pass. This one. Okay. So berapa markah kita? Yay, full mark, 13/13. Alright, so I think that's all for this video. I hope you can try to answer all the questions and try to understand the concept behind each questions. Okay, so see you in the next video. Assalamualaikum dan selamat sejahtera. Bye-bye.